Welcome to the Automation World Get Your Questions Answered podcast, where we connect with industry experts to get the answers you need about industrial automation technologies. I'm David Greenfield, Director of Content for Automation World, and the question we'll be answering in this episode is, what is mean time to repair, which is also known by the acronym MTTR, and mean time before failure, which is commonly referred to by the acronym MTBF, and how they are both applied. Joining me today to answer this question is Sam Russum, the Senior Director of Smart Manufacturing Solutions at Grantech, a system integration and engineering services company. So thanks for joining me here today, Sam.
Hi, David. Really happy to be here again. Thanks for having me.
All right, well, let's get started, right from the core of it. Let's explain mean time to repair. What does this mean?
Sure. Yeah. So this is one of those acronyms that once you break it down, it's kind of self-explanatory, right? So it is essentially the average time it takes to get an asset back up and running once it's gone down. So if your case packer goes down at 12 o'clock and you get it back up and running at 12:30, that took 30 minutes to repair. That's your time to repair. You average all of those downtime periods together over a certain time span, and that is your mean time to repair over that time.
Okay. And where and how is this typically applied? And by that I mean on what types of equipment is it typically used and what does it tell a manufacturer?
Sure. So, mean time to repair, right? It's usually uses both a reflection of maybe your maintenance team's performance, as well as kind of like the nuisance level of a piece of equipment or the implications of its downtime. So, for example, if most of your MTTR on most of your assets is something like 10 to 20 minutes, but one key piece of equipment has an MTTR that's measured in hours or maybe even days, it really can kind of help you prioritize to figure out, what's the most important thing to keep on running. And then, of course, that other common use that I mentioned first was around evaluating some maintenance teams and sometimes even maintenance individuals, right? So maintenance always wants to be driving MTTR down because that means that they're getting things back up and running quicker in the event of a downtime, right? But if you look into the data and you realize that a certain maintenance technician consistently has a lower MTTR than another technician, well, that could be a training opportunity or really kind of indicate to you that some cross training could be required, or maybe it's different training levels of different people. But it can kind of tell you a lot about how your maintenance team is performing.
Okay, thanks for explaining that. So let's move on now to mean time before failure. What does that mean?
Yeah, so another one where if you break down the acronym, it helps you a lot. I do hear this is both mean time before or mean time between failures, but
No. Okay.
essentially it's getting at the same thing, right? Which is how long does it take you between specific downtime events for a piece of equipment? So if machine A goes down and then comes back up at 12 noon, the line runs a while, but then it goes down again at 3 o'clock. That's 3 hours between those two failures of that machine.
Okay. And as we did with mean time to repair, where and how is mean time before or between failures applied? What types of equipment and what does it tell a manufacturer?
Sure. So MTBF is much more of an indicator of your machine and asset performance than it is a personnel assessment, right? So it can still point you to more problematic pieces of equipment, just like MTTR can, right? So lower MTBF numbers mean that a machine is causing downtime very frequently, and may need replacement or maintenance or something like that. It's also a really interesting metric to examine over time, right? So if you have an asset that's its MTBF used to be something like 30 days, but over time it drops to 28 and then 25 and it continues to fail, right? Then you're having a machine that's failing more frequently over time and maybe due for some maintenance or some other type of remediation to try to get it to fail less frequently.
Okay, great. So now that we know what both of the acronyms or the terms mean and how they're applied, let's focus on MTTR, mean time to repair. What are the primary benefits of this to maintenance and both maintenance and operations?
Sure. So again, one of those main ones is it is nice for evaluating maintenance teams and their performance, but there are other kind of more advanced use cases that you can get to too once you've kind of gone through a lot of the basics on it, right? So one example I've seen is manufacturers that are good at tracking mean time to repair, not just by asset, but by specific fault code on that asset. Which can really, again, help to prioritize maintenance activities, and it can kind of help to organize the schedule of that maintenance team, right? So if a specific machine, for example, is showing a in-feed jam fault, and we know those usually take 15 minutes to repair, that can really kind of help your maintenance team to organize their schedule and to figure out when, how much of a priority that would be and kind of how to prioritize their own work. On the operations side, I would say it's kind of interesting to think about how MTTR ties into other more operationally focused metrics like OEE, one of the subjects of your MI's podcast in the past, right? So
Hmm.
if you are improving your MTTR, you should see that reflected in a higher asset availability metric and then a higher OEE score, right? Because that means when you go down, your faulted time, your available time is hopefully being minimized because you're able to repair it quickly. Therefore, your OEE score should be higher.
Okay, understood. And likewise, let's treat MTBF the same way. And what are the benefits of that to both maintenance and operations personnel?
Yeah, sure, sure. So on the maintenance side, MTBF I'd say is really best used around understanding preventative maintenance and finding those opportunities where you can have planned downtime as opposed to unplanned downtime, right? So, for example, if a machine pretty reliably is failing every 2 weeks, but you do know that there's a preventative maintenance activity that you can do in a planned downtime to prevent that, that can really kind of indicate opportunities to take those MTBF numbers up a little bit higher and keep things running longer. On the operations side, again, lower MTBF numbers mean that production assets are failing more frequently and hurting overall productivity, right?
Mhm.
So there are some situations where operators could probably directly influence that MTBF time as well. If you have an operator that knows maybe how to tweak machine parameters to increase throughput, but it also decreases the MTBF and makes the line go down more often, maybe your overall productivity goes down, right? So it's one of those numbers that can kind of help you to understand and balance kind of the overall effectiveness of a line and your influences on overall throughput.
Okay. So, how have these calculations typically been performed, and who's usually responsible for doing that?
Yeah, sure. So a lot of maintenance management systems or CMMSs, right? Computerized maintenance management systems are automatically going to calculate MTTR and MTBF as some of their key metrics. They've been around for a very long time. They're very well accepted in the industries, and a lot of common maintenance solutions are going to use those as some key metrics that are just coming right out of the box. But actually, some operation systems typically do that too, right? So I was talking about OEE a little bit earlier. OEE systems also frequently will calculate MTTR and MTBF based on the fault information and downtime information that they receive. Where that can become a little bit more interesting is when those numbers don't even necessarily match up, right? So maybe your OEE system is pulling data directly from PLCs, whereas your CMMS system is more being managed by maintenance logs and when people log things into the system or things like that. So noticing maybe some of those discrepancies between how those two different systems are reporting that information may provide some insight as well.
So, like most equipment metrics, I'm sure MTTR and MTBF, have some common misconceptions or negative impressions associated with them. I mean, after all, there are few, if any, things in this world that aren't surrounded by a range of opinions, and I'm sure these are not escaping that. So, given that, have you encountered any or many negative impressions of these metrics, and should any of them be seriously considered in certain circumstances?
Yeah, great question. So on this one, one of the issues that I've seen come up sometimes when looking at MTTR and MTBF is focusing too much on each of those numbers in a silo without necessarily thinking about how it's affecting other things. So one of the things that I've noticed is assets that might have, for example, a relatively low MTBF and a low MTTR are said to have a problem with microstops, right? So that's saying a low MTBF means that low time between failures, so failures are happening frequently, but low MTTR, where maybe the fault corrects itself or it's a very quick maintenance operation to get things back up and running. So a line might have a lot of very small faults that don't seem to affect the overall throughput of the line very much in isolation, but their frequency makes them a much larger problem than you might think. So if you're just looking at one of those metrics, if you're just looking at MTTR, for example, you're thinking you're all good because your MTTR numbers are low, which means that repairs aren't taking very long and things are good. But with that paired with the MTBF number and the overall throughput of the line, you can see that you do have a big problem for overall productivity, right? So these are definitely a lot of metrics, of course, are tied to other parts of the organization, and they need multiple numbers to paint the bigger picture. But these are two values that are certainly conforming with that idea. If you were looking at either of them in isolation without the bigger picture, you're probably going to cause more problems than you solve.
So earlier you mentioned both CMMS and OEE as ways of calculating both of these metrics. Are there recommended ways of doing this with either of those types of software or other types of software like enterprise asset management or something else?
Yeah, so honestly, MTBF and MTTR are pretty simple to calculate. And with some pretty basic information, there's a lot of systems that should be able to handle this pretty well, right? So, really, all you need is to know when your assets are down and when they're back up. As long as you have that 1 to 2 pieces of information, you can calculate your MTTR and your MTBF, which is one of the reasons that there are a lot of pieces of software that go out there and do it. Any MES or OEE system will likely be able to do it. Any CMMS system is going to do it based on maintenance and operator logs. But it doesn't mean that if you don't have one of those systems, that you can't get this information yourself. It's really, as long as you have that availability information and kind of know when an asset's up or down, it's one Excel sheet and a quick calculation away from figuring out these types of numbers. So really, anything that you have that is connected to your machine data or is receiving operator or maintenance log information, where you can be running some calculations, is more than capable of being able to help you to get to these numbers.
All right. Well, thank you for joining me for this podcast, Sam. And thanks, of course, to all of our listeners. And please keep watching this space for more installments of Automation World. Get your questions answered. And remember to visit our website at www.automationworld.com to stay on top of the latest industrial automation technology insights, trends, and news.